Hey, welcome to the world of parallel programming. Hope you guys enjoying the series up until now. So, in this series, we are going to begin with the topic of a profiling. Now, it's really important topic, and I would say it's one of the most important topic. So, why? So, it's a very correct question. So, just think like whenever you want to evaluate something, that yes, this is better, this is good to go, or there is an improvement. So all these keywords are being associated with one keyword, which is a profiling. So this development term is actually used to tell that you are measuring various aspects in terms of a memory, in terms of a computation, in terms of a power, in terms of temperature. So all the aspects you are considering as per what you want. And you are making sure that as per that matrix, you are designing a one baseline solution. So whenever you are going to do something better, so that would treat as a baseline. And whatever the improvement what we are going to notice, that we can measure with this profiling. So before we actually start how to create a baseline, how to get started on with comparing and making a speed ups, and then making sure that okay, how much speed ups we achieved, that we can do with profiling. Let's start actually. So how exactly we can apply this profiling in the first place? So let's start with this, that in the last session, what we did was like we just write a simple hello world program. And from that program, what we started was forward is that we see that how we write a make file in the next session, and we are making sure to compile it, and it is working. So now in this profiling, we were using a few of the kernel libraries and the heap kernel calls. So we'll start to see like how that is working, how the communication is flowing. So what exactly? So if you recap again our earlier session, where when we have the GPU devices, so in this GPU devices, there is a process where when we are invoking the heap kernel, so it offloads that heap kernel from the CPU instruction to the GPU scheduler. And then that scheduler will take that kernel event and it will allocate to the individual streaming multiprocessor, which will then take care to execute our kernel. Now, when this kernel is being executed, we need to also evaluate the metrics of how fast this kernel is performing. And we also want to evaluate how our overall code is performing. Because if you want to make something better at job, it's a really important thing to go. So let's get started with the same. So you can find it out here. So we are using the AMD MI300x, and for that we are going to use a Rocprofv3. So it's a latest tool which has been in the market, available in the open source from the AMD, and you can follow this link also in the description mentioned below, and you can see this kind of page you should be able to see, and you have this kind of a syntax. So we have a here summary. So let's go one by one. What each of this term do. So this Rocprofv v3 is nothing but it is a binary file which will be executing. So you can tell it as a executable. And what we are trying to say is we need a summary. And summary of what? So if we tell that we need a system trace, so we will get every system trace. We can also tell it what is the output format it should have. We can also mention what is the output directory we should have. And we need to specify what would be the executable we want to run. So let me do one thing. I copy this over here. And let's say output format, output directory will not specify very quickly. And let's see this command in action. So again, this repo, if you need, you can actually get this repo from this URL, also mentioned in the description below. And you can see this is a structure you will be seeing. You will observe a make file, you will have all these various GPU program files, and this is what we actually studied in the previous session. So let's say what we have this make file written is to actually compile this hello world explicit and create its executable. So I'll just build it once again. So as you can see, the file has been built. I have the executable ready. So what I need to do is I just need to specify what I need and mention slash and hello.exe. As you can see, now we have this result. So for better clarity, I'll zoom out a little bit so you can see what has just happened. So this command of our, it is executed as it should have been, like in the earlier session, like you would have executed the normally. But along with that, it has added some injections into this profiler. So whenever we are running every activity, it is actually monitored. So how it does? So you can see that we have a various trace. So say here, so we have generated a system trace. So here we are getting when we are calling the heap stream create. We are also getting like when is a queue is created. So like we were discussing that whenever we are launching our kernel and we will need it to be allocated into the multiprocessor, streaming multiprocessor and scheduler. So scheduler will using the queue and it will pick up. And there is a wait time also. So when we have our kernel in the scheduler, there is some wait time, and after that wait time, so when the scheduler will pick our kernel to execute, it will need to allocate the memory allocation. So that's what here the job is. And then eventually our kernel, when we launch with the heap launch kernel, that will start to execute. And what it will execute is our this hello GPU. So that is our kernel dispatch. So that you can see that actually kernel has been dispatched for the execution. So this is what the very standard process that we will see. But what else we are observing in here? We are also observing here by the filter that how many times each of this has been invoked, what is the total duration for each of this. So how much time it is creating to create a heap create. And you can observe that the measurement unit is a nanosecond. So here you can observe the majority of your time as of currently, it is going to creating a stream, queue, and the memory allocation, and eventually then dispatching the kernel. So if you see, we just wrote a hello world program. So rather than actually executing the hello world program, we are adding a more time towards actually telling the GPU to print a hello world, which is why we are telling that GPU is designed for a data parallelism task. But anyways, we are here to focus on the how to run a profiler that we are able to successfully run. So as you can see, this is just a sys trace, and we can get any kind of traces. There are various parameters and options available, which we will still explore continue, such as this. I need a heap trace as well. I can do it, and we'll have this separately. So yeah, so this heap trace, we can see that it is stored into the CSV file actually. So if I do so ls-array and we have this folder, so we can list out that folder, and here you can see that it has created all the execution CSV files. Now let's observe that CSV file. Basically, these are the CSV files. So from the most recent CSV file of the execution, so this is a heap API trace. Convert to the table so it looks better. So this is a heap API trace. So if we have a domain, like what was the domain of the compilation, what is the function is being invoked. Okay, so let's observe over here what's just been happening. So now you see, let's split it up to the right and our code. So from this one, if we start to compare, this is a main event. And from that main event, where are we at? So this is a heap stream create event. We are observing this heap stream create event. After that, we are running this kernel launch. So we are also seeing the kernel launch is there. After that, see, if you notice, this is a commented, and we have another heap stream create. So we have another heap stream create over here. And then we have the launch kernel method. So this is a launch kernel method. Then we are also calling the device synchronize method. So we have a device synchronize method also. And if we are getting this error query, so that is also logged over here. Now, if you just notice, this command between the two kernel launch has not been uh, active right now because it's a commented and we are not observing the same over here. But what if we do? So let's try it again. So if I do it and I'll close this one and let us rerun. So make clean will actually clean everything. I'll also remove the old traces and we can run again. So when we run again, the same command for a profiler. And let's come and see over here what we are seeing. So this, we have a new file generated, we have a new program, and as you can notice over here, after heap stream create and launch kernel, we are observing the device synchronize function, which we added. So this is the flow of a profiler. It is tracking everything for us. It is tracking a process ID, thread ID, its correlation ID. We have its start time. We also have the end time. So based on that, we have a lot of execution that we can do. So there are various level of tracing and the profiling. So the more onto this, we'll discuss in the next session about what are the other factors and when should we be using those factors. Okay, thank you for watching. Please do not forget to like, share, and subscribe.